Of all the worlds within our view, apparently ours is the only one with a sea. 350 million cubic miles of salt water, spreading its boundaries over more than 2/3 of the Earth's surface. Yet today, even as we reach for the stars, we know less about this ocean than we do the surface of the moon. The restless sea remains as it has since life first emerged from its waters, unexplored, unknown, its vast resources untapped, its rewards awaiting but men to master it. The sea has long been a challenge to many men of many nations. One of these men was the late President John Fitzgerald Kennedy. Shortly before his tragic and untimely death, he made this statement.
Knowledge of the oceans is more than a matter of curiosity. Our very survival may hinge upon it. The seas offer a wealth of food for the people of the world. Mineral resources on land will ultimately reach their limits. We may be able to extract additional elements in the water. To predict, and perhaps someday to control, changes in weather and climate is of the utmost importance to man everywhere. These changes are controlled to a large and yet unknown extent by what happens in the ocean. Additional research is necessary to identify the factors in this interplay. These are some of the reasons which compel us to embark upon an important national effort in oceanography. This is not a one-year program or even a 10-year program. It is the first step in a continuing effort to acquire and apply the information about a part of our world that will ultimately determine conditions of life in the rest of the world. The opportunities are there. A vigorous program will capture those opportunities.
To meet this challenge, scientists today are working in every part of the world ocean. For these men, these oceanographers, the sea is a complex and demanding laboratory. Its waters must be probed and studied from the surface thousands of feet to the ocean floor. Expeditions must be conducted into areas remote from the centers of scientific research. From the icebound seas of the Arctic and Antarctic to the tropical waters of the Atlantic, Pacific, and Indian Oceans. For the most part, support of this worldwide research effort must come from the federal government. Support to build ships and laboratories, develop the instruments needed to collect data at sea. But the nation's resources for oceanography are limited. If we are to achieve mastery of the sea, they must be wisely managed, efficiently used. Toward this end, the President has instructed his science advisor, as Director of the Office of Science and Technology, to prepare and coordinate a national oceanographic program through the Federal Council for Science and Technology, a pioneering tool in scientific management. Represented on the Federal Council and directly responsible to the President are senior policy advisors from all departments and agencies of the government charged with the scientific and technical progress of this nation. To spearhead the national effort to master the sea, a permanent committee has been established within the Council, the Interagency Committee on Oceanography. ICO has prepared a long-range plan. The goal, full understanding of the world ocean, to improve national defense and promote the welfare, security, and economic well-being of the American people. Participating in this effort are all agencies of the federal government whose statutory responsibilities to the American people include problems in the ocean environment. Each has specific missions in the sea, which contribute to the objectives of the long-range plan. The Department of the Interior is interested in the exploitation of the resources of the ocean. Its living resources, food, which its waters contain in abundance, its recreational resources, enjoyed by so many Americans, the vast mineral resources of the sea, which must be mined and mapped to realize their full potential in the years to come. The Department of Commerce is interested in the sea as a vast highway vital to world trade. Its mission, to assure uninterrupted safe navigation through acquisition and dissemination of knowledge concerning the ocean environment, the weather influenced by the sea, ships designed and built to work at sea. The Department of the Treasury, concerned with aids to marine navigation and safety at sea, a Coast Guard responsibility. The Department of Health, Education, and Welfare is concerned with the impact of pollutants on the marine environment, a problem that is growing with our expanding population and technology. Concerned, too, with the purity of foods from the sea and the effects of marine organisms upon the human body. Responsible for furthering education in the marine sciences. The Atomic Energy Commission, concerned with the effects of radioactive materials on the ocean environment. Specimens collected in support of the national program must be processed and described, a responsibility of the Smithsonian Institution, National Repository of Scientific Knowledge. The National Science Foundation's mission is to encourage the acquisition of new knowledge in all the marine sciences, basic fundamental knowledge essential to the continued progress of our nation. The Department of Defense, responsible for maintaining freedom of the seas and preventing sea-launched attacks on the United States and her free world allies. A responsibility that requires this nation to be in constant readiness to project sea power to any part of the world when necessary for national security. Charged with developing the weapons, vehicles, and tactics essential to command of the sea. This is a mission that demands a thorough knowledge of the Navy's three-dimensional operating environment, knowledge that can only be obtained through basic and applied research, knowledge based on the study of the human factors so vital to exploration and work at sea, knowledge needed to engineer and build at sea, and protect and improve our waterways and coastlines. For these agencies, the world ocean is a common laboratory. Each is using it to obtain knowledge important to its mission. The Interagency Committee on Oceanography provides a forum where coordination in planning, effective use of resources, and exchange of information all work toward meeting the objectives of its member agencies and the nation. Toward this end, the committee prepares annually the National Oceanographic Program. This is designed to assure over the years to come the orderly, efficient administration of one of the most challenging efforts of our time, conquest of this last frontier on our planet. Although the ocean covers more than 70% of the Earth's surface, so little is known about its waters and boundaries that much of the national effort must be directed toward obtaining new knowledge. This quest for basic knowledge is being conducted by scientists representing many disciplines, working at colleges, universities, and research institutions. The goal of basic research is the acquisition of fundamental knowledge, the what, why, and how of ocean phenomena. Answers to these questions are greatly needed to realize the promise of the sea. One important objective of oceanographic research is a broad understanding of the earth beneath the waters of the sea. In the quest for new knowledge, marine geologists are probing through thousands of feet of water to the bottom of the sea. The core pipe hits bottom. The sampler has been driven 40 feet into sediments on the ocean floor. Geologists now extrude the core sample. Millions of years of sedimentation, which must be studied, preserved as a small but significant part of the history of our planet, a key to understanding the climate in ages past and the distribution of minerals, plants, and animal life over the sea. The mountains, valleys, and the deep abyssal plains of the ocean's floor, these must be charted and studied if we are to master the sea. Geophysicists also probe to learn more about the fundamental structure of our planet. The forces of magnetism and gravity over the sea floor must be measured and mapped. The water of the sea, another challenging objective of basic research. Its ever-changing physical and chemical properties must be studied over the entire face of the ocean at different times and at different depths. Here on the new research vessel Atlantis II, water which has just been obtained on a single oceanographic station is analyzed by chemists in a laboratory designed and equipped to handle a variety of experiments simultaneously. Strange that this, the most common substance on our planet, should be among the most complex. Oceanographers are studying and measuring the complex circulation systems of the ocean. Some of this work involves the use of devices that simulate the forces that drive the water of the ocean. However, theoretical work in the laboratory must eventually be verified at sea. Research must also be conducted above the sea to learn more fully the relationships between the ocean and atmosphere. Scientists are probing the skies over the sea, photographing cloud formations in an effort to understand the sea's influence on the weather of the earth. Oceanographers must measure the water-laden atmosphere into which the sea is drawn, soon to fall upon the land, soon to return to the sea. An instrumented balloon to telemeter data on temperature and wind currents. Soon the atmosphere, too, will yield up its secrets. Marine biologists are seeking new knowledge about the life of the sea, the plants and animals comprising more than 4/5 of the living things on Earth. Specimens must be collected at every depth and in all the oceans of the world, identified and described. The relationship between plants and animals must be studied, how they influence and how they are influenced by the chemical and physical properties of the sea, how they adapt to the marine environment. Patterns of behavior must be observed. Sharks. How are they distributed over the oceans of the world? What are their life histories? What senses enable them to seek out their prey and kill? These are only a few of the many thousand questions biologists today are attempting to answer about life in the sea. Thus, the quest for new knowledge is at the very foundation of the national oceanographic effort. Basic research, our investment today for the scientific and engineering progress of tomorrow. Research is also being applied to help solve specific problems in the sea environment, many vital to our security and welfare. Pollution of waters along our coasts is of tremendous concern to federal, state, and local government. To meet this problem, the Public Health Service is studying the distribution of toxic chemicals, industrial wastes, and other pollutants in the ocean. Here in the waters of New Jersey's Raritan Bay, scientists dredge for clams in an effort to measure pollution in selected areas for study. Shellfish are sensitive to harmful chemicals and organisms, and are thus a good barometer as to the degree and distribution of pollutants in the sea. Research here and in laboratories throughout the nation promises to alleviate and perhaps someday solve one of our most urgent problems in the sea. Research sponsored by the Atomic Energy Commission is directed toward understanding the impact of radioactive materials on the ocean environment. Although low-level radioactive wastes are not a major problem in our offshore waters today, we must know more about their distribution and effect upon life in the sea, should this knowledge ever be needed in an emergency. Of concern to all Americans is the preservation and protection of our coasts facing the sea. This is all that remains of a once prosperous Oregon town, washed away by the sea. To meet this problem, the Army Corps of Engineers is conducting research using large wave-making machines. Work here and in other facilities of the Beach Erosion Board will help give engineers the knowledge needed to control the destructive forces of the sea along our many miles of coasts. For this must be an ocean that can continue to be enjoyed, preserved as the birthright of those who work, play, and live by the sea. Off these same coasts and far into the ocean is one of our most important resources, food from the sea. Oceanographic research is vital to realize the promise of our fisheries and assure their wise management for generations to come. Toward this end, the Bureau of Commercial Fisheries is conducting a broad program of research in many areas. Albatross 4, the Bureau's newest stern trawler, performs both fisheries research and general oceanography. Specimens trawled on research cruises provide important information on the distribution and abundance of the living populations of the ocean and their relation to its physical and chemical environments. Oceanographic research is also being applied to meet the problems of national defense. Here at the Navy Electronics Laboratory, scientists work from an oceanographic tower. This research is important to the design and operation of systems for detecting submarines. The bathyscaphe Trieste operates in support of a similar mission. This deep diving research vehicle enables scientists to collect important data on the propagation of sound underwater and verify theories important to anti-submarine warfare. Deep diving vehicles will play an important role in locating and identifying large man-made objects on the ocean floor, a problem that was recently investigated by a Deep Submergent Systems Review Group established by the Secretary of the Navy. These studies emphasize the need for the United States to advance its underseas technology so objects such as missile nose cones and submarines can be recovered or salvaged at any depth and trapped personnel rescued. Thus, many agencies of the government are conducting or sponsoring a variety of research projects to develop equipment and techniques important to their missions. The Interagency Committee on Oceanography provides the mechanism whereby agencies can work together, prevent needless duplication of research effort, and through mutual support, accelerate our national program. An essential part of this cooperative effort is ICO's National Plan for Ocean Surveys. These are large-scale systematic investigations designed to obtain data of all types over a wide ocean area. The Coast and Geodetic Survey is prominent in its contributions to this effort. Its ships operate in coastal and deep ocean areas to meet the requirements of the Department of Commerce and other agencies of the government. Here in the Gulf Stream, specialists rig buoys to measure ocean currents. Each buoy will be anchored in a position fixed by precise navigation. Data are radioed back to the ship to give continuous around-the-clock observations. Ships of the Coast and Geodetic Survey are today supporting the ocean survey effort in areas as yet uncharted, unexplored. Data collected are used to make charts for marine navigation and as surveys for the future development of the sea as a natural resource. The oceanographic work of the Department of Commerce is helping increase our ability to predict sea and weather conditions and develop information important to our ocean-going commerce. A predictable sea will result in faster, more comfortable voyages. Speed and protect new ships designed and built to meet the ocean on better terms. Violent changes across its surface can be known in time to warn and evacuate threatened areas. Hurricanes, typhoons, storm-generated waves, perhaps eventually even these destructive forces can be controlled by science. A predictable sea will be a safer sea, a responsibility to which the United States Coast Guard has been traditionally dedicated. Today, Coast Guard ships operate in all the oceans of the world in support of the national program. Greenland, source of icebergs threatening the North Atlantic shipping lanes. One important Coast Guard mission is the International Ice Patrol, where oceanographic data must be collected to predict the movement of ice into the North Atlantic. This work contributes to the ocean survey effort. In the Atlantic and Pacific Oceans, station ships are especially useful for collecting data in one place over a long period of time. Recently, Congress authorized the Coast Guard to expand the oceanographic capabilities of ships operating on ocean stations. Coast Guard light towers are also good platforms for making observations around the clock. Icebreakers of the Coast Guard are often the only ships that can penetrate ice-locked seas in the Arctic and Antarctic. Observations of ice, sea, and atmospheric conditions provide valuable information about this inaccessible but important part of the world ocean. The U.S. Naval Oceanographic Office works in direct support of naval forces at sea. From here, Navy and civilian specialists coordinate a worldwide data collection operation. Oceanographic ships of the Navy obtain information needed for maps, charts, and atlases, and supply data for environmental prediction systems used in naval warfare. This work requires trained technicians to make observations in all areas of the world ocean. Water samples to be checked for temperature, salinity, and other important information. Navy ships are testing and evaluating new instruments to study the sea. Here on the USS San Pablo, the thermistor chain. Each of its spine-like segments electrically senses temperature at a specified depth. Together, they give the oceanographer a better understanding of the temperature structure of the water, information needed to predict sonar conditions under the sea. Thus, throughout the Navy, the survey effort is being accelerated to provide the fleet with the current on-the-spot oceanographic intelligence so important to naval operations at sea. Of primary importance to the entire research and survey effort are ships designed and built for oceanography. To meet this urgent requirement, the Interagency Committee on Oceanography is coordinating a long-range program of ship construction. Already, the first of these new vessels are working at sea. Research has also moved into the air over the sea. This Navy plane is equipped with instruments to collect oceanographic data. As instrumentation improves, aircraft may fill a large gap in the ICO's data collection program. Other platforms are being developed to study the sea. This floating instrumentation platform, FLIP for short, offers the scientists stability for acoustics research. FLIP is towed to her oceanographic station. Ballast tanks are flooded, and the long cylinder slowly submerges. In the bow, instruments and living quarters for the scientific party. In an upright position, FLIP rides even in heavy seas with a minimum of interference to its instruments, 300 feet underwater. Deep diving exploration vehicles are also being developed. For today, research is moving underwater. Instrumentation is also vital to the national program. Advanced buoys for collecting many types of oceanographic data. Scientists plan to establish networks to telemeter data to ships, aircraft, and eventually to orbiting oceanographic satellites. Buoys are especially needed to collect data for the weather services of the Navy and Air Force and the United States Weather Bureau, an important contributor to the national program. The Interagency Committee on Oceanography is encouraging the development of instrumentation by informing industry of the scientific community's needs. Already, these efforts are beginning to yield results as the energy and resources of American industry are applied to meet the challenge of the sea. To test, evaluate, and intercalibrate these new instruments, the Naval Oceanographic Office has established in Washington an instrumentation center. Work here will help assure accurate, uniform measurements. New instrumentation will multiply greatly the output of data collected on research and survey cruises. To handle this tremendous volume, modern data processing facilities are urgently needed, a problem currently being studied by the Interagency Committee on Oceanography. Biological specimens present unique problems. For these are data that cannot be digitized or filed. To process specimens collected for the national program, the Smithsonian Institution has established a sorting center. This new approach to data retrieval will be of great help to scientists engaged in taxonomic studies. Also in Washington, the National Oceanographic Data Center, central clearinghouse for data received from government agencies, scientific institutions, and other nations engaged in research and survey work. Here, data are compiled, processed, and preserved in a form permitting rapid retrieval. Shore facilities must also be expanded to study data collected at sea and carry out the many research projects requiring laboratory work. With government assistance, modern marine laboratories have been built and equipped for research in many areas. The new tools of oceanography are numerous. As the national program accelerates, scientists require advanced equipment, better instruments, facilities of all kinds to support research efforts involving many disciplines. An important function of the Interagency Committee on Oceanography is to anticipate these requirements and work with participating agencies and institutions to assure that scientific facilities are used to the best advantage. But laboratories and equipment are of little value without experienced, creative scientists. As the national program accelerates, specialized knowledge in many scientific disciplines and in an increasing variety of technologies is needed. To follow in the footsteps of the scientific leaders of today, the Interagency Committee on Oceanography is studying ways of recruiting promising college and university students and preparing them for careers in oceanography. Federal grants from the National Science Foundation and the Office of Education are encouraging many young men and women to continue their studies in the marine sciences. These are the scientists of tomorrow who will seek their challenge in the sea. The Navy's far-reaching 10-year oceanographic program, TENOC, requires trained personnel. At the Naval Academy and throughout the Navy, training is being accelerated. Allied officers, too, are receiving specialized instruction at the Naval Oceanographic Office, encouraging evidence of the growing cooperation between the nations of the world in advancing the science of oceanography. The world ocean, belonging to no nation, yet a common laboratory for all, is so large, so complex, that international scientific investigation is essential. To assure that the efforts of the United States are coordinated where possible with the 43 other nations having oceanographic programs, the ICO is working through the Department of State at the United Nations to participate in established scientific expeditions.
This 64 program is going to be a keystone to the progress we're going to make.
The tropical Atlantic, Equilant, was recently the scene of an important cooperative effort involving the operations of ships from Argentina, Brazil, the Republic of the Congo, Brazzaville, the Ivory Coast, Nigeria, the Soviet Union, and the United States. Representing the United States were the Coast and Geodetic Survey, Navy, Coast Guard, and the Bureau of Commercial Fisheries. All made ships and research facilities available to the scientific community through the Interagency Committee on Oceanography. The waters of the tropical Atlantic have the potential of becoming a major world fishery. In the Indian Ocean, the National Science Foundation is coordinating the participation of federal agencies and more than 100 American colleges and universities in the International Indian Ocean Expedition. Among the many areas of scientific interest are the geological and geophysical characteristics of this unique and relatively unknown part of the world ocean. This expedition will not only contribute to the United States effort, but also promises to stimulate science in the nations of the Indian Ocean, many urgently needing protein food. This is one of many challenges to be met by the nations of the world. It is estimated that 440 billion pounds of fish could be taken from the oceans of the world each year without seriously depleting its abundant stock. 440 billion pounds, 5 times the world's present annual catch. Thus, through international cooperation and an accelerating national program, knowledge of the sea is being broadened to help conquer this last frontier on our planet.
Seas around us represent one of our most important resources. If vigorously developed, this resource can be of great benefit to the nation and to all mankind. But it will require concerted action, well directed, with vision and ingenuity. It will require the combined efforts of our scientists and institutions, both public and private, and the coordinated efforts of many federal agencies. It will involve substantial investments in the early years for the construction and operation of ship and shore facilities, for research and surveys, the development of new instruments, for charting the seas and gathering data, and the training of new scientific manpower. It will be an exciting enterprise in which all Americans should take part. The sea is all around us. It is part of our lives. We should master it. We should know about it. And I'm glad that the United States is committed to this great effort.